Hello students, how are you? I hope you all are doing great today. My name is Renu Rathi and today we'll be learning our very interesting topic, that is prime numbers. Now, in this chapter we will learn about multiples and factors, common multiples, common factors, various types of numbers, finding prime number and composite numbers, checking if two given numbers are co-primes and then their divisibility test and properties of divisibility. Now, let's start with the multiples and factors. We have studied about the multiples and factors. Products of a number multiplied are different. Numbers are the multiples of that number, and if the number multiplied by the factors of that number. So, the factor of a number can divide the number fully. Now, in example number 1, the multiples of 3 are, all of these are multiples of 3, and in the same way 3 into 1, 1 and 3 are the factors of 3, then 3 into 2, 6. So, 2 and 3 are the factors of 6. 3 are the factors of 9. In this way, we can say that a factor is a complete divisor of that number, but a multiple is said to be a multiple of each of its factors. In example number 2, we have to find the factors of 16. All the factors of 16 are possible pairs whose product are 16. So here all of these are the factors of 16. We can see that 1 is a factor of every number, so the number itself is a factor of its own, and 1 is the only number which has only one factor, that is 1. In example number 3, we have to find the factors of 36 and 63. These are the factors of 36, that is 1, 2, 3, 4, 6, 9, 12, 18 and 36, and the factors of 63 are 1, 3, 7, 9, 21 and 63. In a multiplication table, we can see the common multiple and common factors of the different numbers as given below. Now, here is our common multiples. Out of these, you can see that 12, 24, 36, 24, these are our what? Common multiples. Now, we can see that each row contains the multiples of first number in that row. Thus, the multiple of 3 are all of these numbers and multiples of 4 are all of these numbers. So, we observe that a few numbers like 12 and 24 appear in both of these rows. So, we have also know that 36 and 48 in both the rows if we extend these rows. So, such numbers which are a multiple of both 3 as well as 4 are our common multiples of 3 and 4. So, here are 12, 24 and 36. These are the common multiples of 2 or more numbers as they are endless. Now, the common factors, prime time. On the given number line, we can see that 6 is a common factor of 12, 18 and 24. So, we can find that the common factor of these numbers are factors of 6, 12, 18 and 24. So, 6 is our common factor of these numbers. Various types of numbers. Even numbers, multiples of 2, these are the multiples of 2. Odd numbers, numbers which are not a multiple of 2, these are not multiple of 2. Prime numbers which has exactly 2 factors, that is 1 and the number itself. So, these all are what? Prime numbers. Next is our composite number, a number which has more than 2 factors, that is our composite number. So, each of these numbers is what? Our composite number. Now, we can see that 1 is neither prime nor composite, 2 is the smallest prime and 2 is the only even prime number. So, all other even numbers are composite numbers. Here we have to find prime and composite numbers, that is from 1 to 100. So, what we will do here, to find the prime composite number from 1 to 100, a Greek mathematician Aristotle's has given us a method. Under this method, we will proceed. We will prepare a table from 1 to 100. We will take 10 numbers in each row. We know that 1 is neither prime nor composite, so we separate it from the box. We will encircle the 2 as and cross out every multiple of 2. We will encircle 3 as prime number and cross out every multiple of 3, and we do not mark which has already been crossed out. After that, in step 5, we will encircle 5 and then cross out every multiple of 5. Then encircle 7 and cross out every multiple of 7. Then you have to continue this process till up to 100 are either encircled or crossed out. So, what are the sieves? We have noted that 1 is neither prime nor composite. All encircled numbers are prime numbers and all crossed out numbers are composite numbers. So, here are all the numbers, and all the prime numbers that are between these numbers are 2, 3, 5, 7, 11 and so on up to 83, 89 and 97. Now let's look at the twin primes. A pair of prime numbers having difference of 2 are known as twin prime numbers. So these are our pair of twin primes, that is 3, 5, 5, 7, 11, 13, 17, 19, 29, 31, 41, 43, 59, 61 and 71 and 73. Next is our prime triplet. A set of 3 consecutive prime numbers differ by 2 and the only prime triplet is 3, 5, 7. Co-prime. 2 numbers are said to be co-prime if they do not have any common factor other than 1. So we can see that 2 prime numbers are always co-prime to each other. 2 co-prime numbers need not be prime numbers. For example, 4 and 9, they are co-prime but they are not prime. Now the first common multiple of 2 co-prime number is always equals to their product. Here is our example. We shall show that each of 3, 5, 4, 7 and 16, 25 is a pair of co-primes. So the only common factor 3 and 5 is 1. 3 and 5 is a pair of co-prime. In the second one, the only common factor of 4 and 7 is 1. It is a pair of co-prime and 4 is composite and 7 is prime. The only common factor of both of these numbers is each one is composite. So similarly, all of these are also a pair of co-prime numbers. Now checking if 2 given numbers are co-prime or not. To see the 2 given numbers are co-prime or not, we will find possible factors of numbers. Now if 1 is the only common factor of 2 numbers, then the given numbers are co-prime. For example, the factor of these numbers are 16 and 21. We see in both numbers 1 is the only common factor. Now let's look at the perfect numbers. Now if sum of all the factors is 2 times the number, then the number is called a perfect number. For example, we can see all the factors of 6 here. Then sum of all the factors of 6 is 12, which is 2 times the number 6. So it is a perfect number. Now in another example, we take number 28 and when we did the sum, it becomes 56. So 56 is double the number 28. So 28 is also a perfect number. Now here we have to write all the factors of 36 and 56. So all the factors of 36 are 1, 2, 3, 4, 6, 9, 12, 18 and 36. All the factors of 56 are 1, 2, 4, 7, 18, 14, 28 and 56. Here we have to write first 5 multiples of 7 and 11. First 5 multiples are 7, 14, 21, 28, 35 and 11 are 11, 22, 33, 44, 55. In example number 6, we have to find 2 numbers whose sum is 15 and product is 56. So here is our factors of 56 and sum of 7 and 8 is 15 and the product of 7 and 8 is 56. So the 2 numbers are 7 and 8. Now let's start with exercise 4.1. In the first one, we have to fill in the correct option in the OMR sheet. The correct factors of 32 are. That is first part. That's how you can complete the remaining part. Next is divisibility test for 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. Divisibility test 2, if a number ends with 0 or an even number, divisible by 2. Example 1 and 2, none of these numbers are divisible by 2 and all of these numbers are divisible by 2. Divisibility test of 3, if sum of digits is divisible by 3, then the number is also divisible by 3. We have considered this number. Here the sum is 28, which is not divisible by 3, so the number is not divisible. In example number 2, here the sum is 24, which is divisible by 3, so the number is also divisible. Divisibility test of 4, if the last 2 digit sum is either 0 or divisible by 4, then the number is divisible by 4. Here the example 94 not divisible by 4, so the number is also not divisible. Here 52 is divisible by 4, so the number is also divisible. Now divisibility test of 5. If the number ends with 0 or 5, then it is divisible by 5. In example number 1, none of these numbers have 5 or 0 in their unit place, so it is not divisible by 5. And in each of these numbers, all of these have 0 or 5, so it is divisible by 5. Now divisibility test of 6. If a number is divisible by 2 and 3 separately, then the number will be divisible by 6. For example, none of these numbers are divisible by 6 and each of these are divisible by 6. Divisibility test by 7. If the difference between twice the ones digit and the number formed by the remaining digit is either 0 or divisible by 7, then the number is divisible by 7. Like in example number 1, we have considered this example 137. So it is not divisible by 7, so it is not divisible by, number is also not divisible. Now in the next one, this number, the answer is 122, which is not divisible by 7, so it is not divisible. In example number 3, here we have 672, which is divisible by 7, so that means the number is also divisible by 7. Divisibility test of 8. Now if the last 3 digits of a number is either 0 or divisible by 8, then the number is also divisible by 8. For example, this is our number and the number formed by, this is 348, which is not divisible, so the number is also not divisible. Now in example number 2, here the last 3 digits are 152, which is divisible by 2, so the number is also divisible. Divisibility test of 9. If the sum of the digits are divisible by 9, then the number is also divisible. For example, when we did the sum 20, not divisible by 9. In this one, we have 18. 18 is divisible by 9, so the number is also divisible. Now divisibility test of 10. If the last digit is 0, that means the number is divisible by 10. Here is our example. None of these numbers have their ones digit 0, so not divisible, and all of these have 0 at their ones place, so they are divisible. Now divisibility test of 11. If the difference between the sum of digits at odd place and at even place is either 0 or divisible by 11, then the number is divisible by 11. For example, sum of digits in odd place 13, 13 minus 13 0, so that means the number is divisible. In example number 2, we have considered the number this. Now the sum on odd places is 24, even place 2, and 22 is also divisible by 11. In the third one, odd places sum is 19, even places 10, 9 is not divisible by 11, so this number is also not divisible. Now let's look at the properties of divisibility. If a number is divisible by another number, then the number is also divisible by the factors. For example, 48 divisible by 12, so 48 is also divisible by 1, 2, 3, 4, 6 also. Now next is, if a number is divisible by two co-prime numbers 3 and 2, then 48 is also divisible by 6. Now if a number is a factor of two given numbers, then it must be a factor of their sum. Here 12 is a factor of 36 and 48, so it is also a factor of 84 also. Now if a number is a factor of two given numbers, then it will also be a factor of their difference. For example, 12 is a factor of 36 and 48, so 12 will also be a factor of 12 also. Now let's start with exercise 4.2. In the first part, here we have to test the following numbers by divisibility test by 2. So first one and second are divisible and third is not. That's how you can complete the remaining part. Now let us summarize what we have learnt earlier. A number is divisible by 2 if it's any of its digits is 0, 2, 4, 6, 8, by 3 if sum of its digit is divisible by 3, by 4 if the number formed by tens and ones digit is divisible by 4, by 5 if ones digit is 0 or 5, by 6 if it is divisible by both 2 and 3, by 7 if difference between the ones digit and the number formed by the other digit is either 0 or a multiple of 7, by 8 if the number formed by 100 tens and ones digit is divisible by 8, by 9 if sum of the digits is divisible by 9, by 11 if the difference of the sum of digits at odd place and even place is either 0 or a multiple of 11. Now let's start with the chapter and exercises. In the first part, we have multiple choice question. Fill the correct option in the OMR sheet. A number this is divisible by 2. That's how you can complete the remaining part. Now here is the assertion and reasoning question that you have to solve it by yourself. Now I hope you have understood the chapter pretty well. You just have to practice the exercise question and don't forget to revise this topic again.